By mid-2026, text-predicting large language models like GPT 5.4 and Claude Fable 5 are integrated into the global enterprise ecosystem at every level. These systems autonomously write and execute production-grade code, manage complex software workflows, and replace high-level knowledge work across entire industries. To maintain this scale, cloud providers are committing tens of billions of dollars to the infrastructure, securing massive gigawatt data centers, and locking in multi-year silicon supply deals just to host these specific models. The consensus within Silicon Valley is practically absolute. Scaling these text prediction models is the definitive path to achieving artificial general intelligence. But Yann LeCun, a foundational figure in modern AI, argues that relying exclusively on large language models is a technological dead end. His critique is specific. LLMs are statistical engines that predict the next word in a sequence, but they possess no underlying comprehension of how the physical world actually works. To prove this, LeCun launched a Paris-based startup called AMI Labs, instantly securing a $1.03 billion seed round from investors like Bezos Expeditions. The company is ignoring text generation entirely. AMI Labs is dedicating its capital to a different architecture known as world models. A $3.5 billion valuation for a pre-product startup signals that institutional capital is aggressively hedging against the text-based consensus. Look at this diagram comparing how two different systems process information. On the left, we have a linear sequence of text tokens. An LLM analyzes these tokens in a complete vacuum, blind to spatial awareness. On the right is the architecture of a world model. This system is trained specifically to simulate cause, effect, spatial reasoning, and the laws of physics. By understanding variables like mass and gravity, it can accurately infer the physical consequences of an action before it happens, mimicking human intuition. While text models require scraping the entire public internet to learn grammar, a world model learns by interacting directly with simulated 3D environments. True intelligence requires physical intuition. Memorizing the encyclopedia is not enough to navigate the real world. This architectural shift is already happening in applied high-stakes sectors where text-based AI is functionally useless, most notably in autonomous driving. Waymo uses Google's Genie 3 to build a hyper-realistic world model, generating synchronized 2D video and 3D LiDAR data. This trains its AI on dangerous edge cases without putting real cars on the road. Hardware developers are also moving in this direction. NVIDIA just released Cosmos 3, an open model designed specifically to power physical AI and robotics. These models process text, video, and physical actions simultaneously to predict the immediate future state of a complex, moving environment. While consumer chatbots capture the headlines, the trillion-dollar infrastructure layer is aggressively preparing for a physical AI revolution. Right now, global AI development is a tightly guarded duopoly, controlled by massive U.S. corporate entities and Chinese state-backed laboratories. AMI Labs is sidestepping this dynamic by committing to build and release its world models as open-source systems. This strategy positions Europe as a highly funded sanctuary for open, democratized AI research that exists outside the current power structures. LeCun's third path represents a strategic attempt to break the centralized control of modern AI, ensuring the software that understands the physical world remains accessible to everyone. As text prediction AI approaches maturity, it is rapidly becoming a commoditized tool available through any standard cloud subscription. The race for physical AI represents the next frontier, unlocking the technology required for fully autonomous systems, advanced manufacturing, and robotics. The challenge for AMI Labs is proving that $1 billion and a radically different architecture can outpace the massive momentum behind traditional LLMs. Understanding language provided the first interface for AI. The transition to world models allows the technology to exit the screen and operate within the physical world, the space where the bulk of the global economy functions.